Welcome to Math TV with Professor V. This is Intermediate Algebra, video lecture number 18 on multiplication of polynomials. Now, in the previous lesson, we added and subtracted polynomials. So to make sure we keep things straight, we're just going to do a quick little reminder. When you're adding or subtracting, you can only combine like terms. And be sure that when you're doing so, you leave the variable portion of each term alone. Do not touch. And all you do is simply combine the coefficients according to whatever operation you're using. So in this case, I'm going to take 4, add it to 8, so that's going to give me 12, and then you leave that x cubed alone. Don't mess with it, okay? Good. Now the difference here, when we're multiplying two terms, right, we multiply the constant portions. So 4 times 8 would be 32. And then we're going to have to apply our laws of exponents, and we add the powers on each of the variables. So x cubed times x cubed is going to be x to the 6th. Just as a little refresher, 4x cubed means 4 times x times x times x, right? That's 4x cubed. And 8x cubed is 8 times x times x. So if you count them up, you've got 6 x's. That's why we have x to the 6th. But who wants to write it out that way? So what we do is we just add up the exponents, bada bing, bada boom. Now, we can multiply other kinds of monomials. You remember the term monomials? It's a polynomial with one term. And we can do so even if they are of multiple variables. So we have here negative 5x to the 4th y squared times 7x cubed y. So to start off, you're going to multiply the coefficients or the constants by each other. So negative 5 times 7, that's negative 35. And then we're going to take x to the 4th times x cubed. Those exponents we will add. So that's going to give us x to the 7th. And then similarly, we're going to take y squared times y. Remember that little lonesome y over here? That's really y to the 1st. So y squared times y is going to be y to the 3rd. All right, so now we're pretty good at multiplying monomials. That's really all there is to it. Let's expand and multiply general polynomials, so more than just one term. First example we're going to look at here is a monomial. 2x to the 4th is a monomial times a polynomial, specifically a trinomial, right? 3 terms. Well, in this case, we're going to apply the distributive property and distribute the 2x to the 4th across each of the terms inside the parentheses. So I'll list it out once the long way and then never again, because you don't have to write out this next step every single time. So you would take 2x to the 4th multiplied by 3x squared plus 2x to the 4th times 2x minus 2x to the 4th times 5. All right, now since this is intermediate algebra, you should have been exposed to this distributive property and working with polynomials a little bit already in beginning algebra. So most of the time we don't write out the line that I have up above. You can just go straight to multiplying everything. So 2 times 3, that's going to give me 6. X raised to the, add them up, 4 plus 2 is 6, good, plus, and then multiply 2 times 2, that's going to be 4. I have x to the 4th and then x to the 1st, so that's going to be x to the 5th minus 2 times 5, so that's 10, and x to the 4th is the only variable. So that's our final answer there, okay? I personally have no problem when my students just jump to this last line that I'm trying to box. There we go. Okay, good. Now, example B, we have 2 binomials multiplied by each other. And in this case, we need to FOIL. So what does FOIL stand for? You've probably heard it a bunch of times. You take the product of the first terms in each of the factors, then the outer terms, then the inner terms, and then the last terms. Some people like making a box. I never got into the box, but if it helps you, go for it. So first product is going to be x times x, so that's x squared. Outer product is going to be x times -3, so -3x. Inner product is 8 times x, so that's 8x. And then last product, -24, 8 times -3. Should we box it? Only if you want to lose points. Notice we have like terms here, -3x and +8x. So combine those up, x squared plus 5x minus 24. Now we can box it, yes, yes, yes. Now, if you'll notice, when you're foiling, and if each of the outer terms here, the first terms, x and x, have a coefficient of 1, you can actually jump straight to the final answer. What do I mean? Well, notice 8 plus -3 gives me 5, and 8 times -3 gives me -24. So you can skip that middle step. All right, you probably already noticed that anyhow. Now looking at example C, we can't use the shortcut that I talked about. Why not? Because there's a 3 in front of this x. It ruins it for everybody. So we do have to sit there and FOIL this one all the way out, okay? Here we go, 3x times x, first product, that's 3x squared. Outer product, 3x times 5, that's going to be plus 15x. Inner product, -1 times x, that's -x. And then last, -1 times 5, so -5. Anything else you notice we can do? Yep, combine those like terms in the middle. So we've got 3x squared plus 14x minus 5. And that is it. Good. So hopefully you feel pretty comfortable with your foiling. Now let's look at another example. It's getting fancier, guys. We've got x plus 5 times 3x squared minus 7x plus 1. So notice we have to take our foiling up a level because now we have 3 terms in the second factor that we're multiplying out. So just stay super organized. I'll show you what I like to do. So first take that x and you're going to distribute it across to everybody. Okay. So x times 3x squared, that's 3x cubed. X times -7x, that's -7x squared. And then x times 1, that's just plus x. All right, so now I'm done distributing x. I'm going to erase this so it doesn't get so messy. And then now I'm going to distribute the 5 to all of the terms in the second factor. Now watch this. 5 times 3x squared, that's 15x squared, right? Instead of writing everything in one long line, I'm going to drop it down and put the plus 15x squared beneath the other x squared term. Okay, 5 times -7x, that's -35x. And then 5 times 1 is plus 5. And then now to get my final answer and combine like terms, I don't have to be searching all over the place to try to find everything because I've already lined up my like terms. Voila. So here we go. It's okay to add left to right this time. Oh my goodness, does it feel naughty? So we've got 3x cubed plus 8x squared minus 34x plus 5. And that is it. I would box that if I were you. Looks good. Okay, next one. Oh my goodness, we've got 3 terms in the first factor, 3 terms in the second. We're gonna stick with the method that I showed you for example D. We're just gonna have a third row, right? Why don't you guys go ahead, pause the video, and give it a go, and then we will continue. All right, did you pause it? Did you try it? Here we go. So we've got m cubed to distribute first. So this is going to be 2m to the 5th plus 4m to the fourth plus 3m cubed. Good. Now let's distribute the negative 2m. I erased the arrows, otherwise it just turns into a hot mess, you know? Okay, so negative 2m times 2m squared, that's going to give me a negative 4m cubed. So let me put that underneath my other m cubed, so I'm lining up my like terms. Then I have negative 8m squared minus 6m. Okay, almost there. One more round. I'm going to distribute the 1. Oh, that'll be easy. So 1 times 2m squared, that's 2m squared. So I'm going to put it under my other m squared. Plus 4m plus 3. Okay, now add everything up. So we've got 2m to the fifth plus 4m to the fourth. This is going to give me a negative m cubed. 3 minus 4, negative m cubed. This is going to give me a negative 6m squared. What do we got over here, guys? We've got a negative 2m. And then little plus 3. There he is. That's it. Okay. Make sure you focus. Don't do anything silly, otherwise it'll just mess the whole problem up, right? Good. Last one like this, example F, x plus 3 squared. Now remember, when we write the squared term outside the parentheses like that, it's basically an abbreviation for writing out x plus 3 times x plus 3. So I'm going to show you a little shortcut to get to the final answer, but before, let's just FOIL it out so we know what the result should be. This is going to be x squared plus 3x plus 3x plus 9. So we'll end up with x squared plus 6x plus 9 as our final answer. What do you think the biggest mistake is that students make when they see something like this, a problem like this, x plus 3 squared? Maybe you thought to do it, huh? They just square the x and they square the 9, and that is not true. Don't do that. They forget all about the poor little 6x. Okay, so I'm going to show you now how to square a binomial. So basically how to get from here to the last line in one step. There's a pattern, obviously, but if you feel like it's too dangerous to apply the pattern, then my advice to you is write it out twice and just FOIL if it's safer until you feel comfortable, okay? However, as is mentioned, certain products like these occur so frequently that the shortcut patterns will make a difference long term if you learn them and become comfortable with them. So first one here, if you have the quantity a plus b squared, shortcut way of multiplying it out is you square the first term, you keep the same sign that's between the two terms, and then you double a times b, so you have 2ab plus b squared. The last one's always positive, so that's going to match. Similarly, a minus b squared, if you multiply it out, it's going to be a squared minus 2ab plus b squared. So notice a couple things. Whatever sign is here between the two terms, that matches the sign in front of 2ab. And the last term is always positive, b squared. Why is that? Well, say we sat down and FOILed this out. Okay, so you'd have a squared plus, there's ab plus ba plus b squared. Notice, since they're both positive, of course, b squared is going to be positive, and then those are both ab, essentially. Similarly, if you take a minus b squared and FOIL it, you would end up with a squared. Now here's where the minus comes into play, right? Minus, oh, I skipped a step in my head. Minus ab minus ba, and then plus b squared, because negative b times negative b is positive b squared. So that's why both of them end with a positive b squared. And then whatever sign is in the middle between a and b, that's the sign on 2ab. Okay? We'll practice. If it just is too much, though, you can FOIL out. Okay? So caution, use this pattern carefully. If not, expand. That means write it out twice and FOIL. If you just can't be trusted. Okay, so here we go. We've got 3x plus 2 quantity squared. So 3x is your A and 2 is your B. So here's the pattern. You take A and you square it. Since it's 3x plus 2, I'm going to put a plus now. And then you have 2ab. So that's 2 times 3x times 2. So here's a squared plus 2ab plus b squared is 2 squared. Okay, I'm writing out more than you need to. If you get to a point where you can just do all this in your head, fabulous, okay? So last step to simplifying it out, 3x squared. Please be so careful. You have to square the 3 and the x. Oh yes. So then it's going to become 9x squared plus 2 times 3x, that's 6x times 2. We've got 12x plus 2 squared is 4. And that's our final answer. Now you might say, I just hated that. That was one of the most confusing things I've watched today. And I understand it takes a while to get used to it, but I'm going to give you this word of advice. Very shortly, we're going to have to factor. Factor meaning you're going to be given this expression and you're going to have to break it down or rewrite it, factor it as 3x plus 2 squared. And that's a hard one for students to recognize, especially when they don't learn and memorize the pattern because they can't recognize it in order to factor and go backwards. So I know right now going forwards, multiplying it out might be hard, but I promise if you put in the time to get used to it, it'll pay off in the long run. Okay, enough with my words of advice. So 5r minus 6 quantity squared. This one I'm not going to write out step by step. Okay, let's try to do it in our head. So square the first one. So remember, you have to square the constant and the variable. So it's going to be 25r squared. Since there's subtraction there, put a minus sign next. Now here's the fun part. Take 5r, multiply by 6, so that's 30r, and then double it. That's what 2ab is. Multiply the two terms by each other, double it. So 5r times 6, that's 30r, and then double it, 60r. Very good. Plus, and then now square the last term, 36. Replay that if you need to hear it one more time. Okay, let's move on to, whoa. I'm telling you, I just got to do it quickly and furiously and then it cooperates. All right, last one, 5x plus 1/2 y quantity squared. All right, I'll write this one out step by step. So remember, it's going to be a squared plus 2ab plus b squared. So here's my a, here's my b. So a squared is going to be 5x quantity squared plus 2 times 5x times 1/2 y, 2ab plus 1/2 y squared. Okay, this is just to help you guys see the pattern. After this point, hopefully with enough practice, you'll just go straight to, okay, square the first term, right? Square the 5x, that's going to become 25x squared, plus you take the first term times the second term. So 5x times 1/2 y, and then double it. Ooh, that's good, because doubling it will cancel with the 1/2. So now I just have 5xy plus, and then square the last term. Be careful, 1/2 times 1/2 is 1/4, yes? Y squared. And that's it. Okay, lovely. All right, now the next famous product is of a sum and difference, when you have two factors that are what we call conjugate pairs. So conjugate pairs are when you have two terms and then the same two terms, but the first time they involve addition and the second time it involves subtraction. When you multiply out conjugate squares, we get a very famous pattern or result. So the first time I'll do it the long way so we can see what's going on. So if you take a plus b times a minus b, a times a, that's a squared. That's a times negative b minus ab plus ba minus b squared, right? Because one was positive, one was negative. And then look what happens. I have a negative ab and a positive ba. So these guys cancel out. And all I'm left with is a squared minus b squared. And this result here is called a difference of squares. Okay. And so notice AB and BA canceled out this time because one of them was positive and one of them was negative. So you get a difference of squares when you're multiplying conjugate pairs. Only two terms result. Don't confuse that with what we just did. When you're squaring a binomial, both are positive or both are negative. So what does that mean for us? The ABs do not cancel out. You should have three terms in your answer. So three terms here, three terms, okay? After you multiply it out, when you do a difference of squares, there's only two terms. And they always will have subtraction between them because one of the factors had addition and the other factor had subtraction. All right, fabulous. Let's look at some examples. First one, x plus 4 times, or x minus 4 times x plus 4. So notice we're multiplying out conjugate pairs. So I'm just gonna be left with the difference of squares. That's gonna give us x squared minus 16. Oops, no x. No x, just 16. I got too excited there. You don't have to write out the plus 4x, the minus 4x. It's just going to cancel, okay? All right, example B, we've got 5x plus 2 times 5x minus 2 minus x plus 3 squared. So we're going to tackle this in two parts. Notice here, we're multiplying out conjugate pairs. So 5x plus 2 times 5x minus 2, that's going to be 25x squared minus 4. Very good. Now, I have to be careful and multiply out this x plus 3 squared with caution. So keep that minus sign there, put some parentheses, and now we're going to use our shortcut formula. So square the first term. That's going to make it x squared plus take the first term times the second term and then double it. So x times 3, that's 3x. Double it, 6x. Very good. Plus square the last term, that's 9. All right, now we need to distribute the negative to all of the terms in the parentheses there. So we've got 25x squared minus 4 minus x squared minus 6x minus 9. Do we have any like terms to combine? Yes, we do. We've got 25x squared and negative x squared. So that's 24x squared. And then just a lonesome negative 6x. And then negative 4 and negative 9, that's going to give us negative 13. All right, that one's done. Last one, 2x minus 3 plus 5y, and then 2x minus 3 minus 5y. Now, before you get ready to start triple foiling this bad boy, look, 2x minus 3 is repeated, yes, in both of the terms. What if instead you had been given the following problem? What if instead it was a plus 5y times a minus 5y. What would you get? So it would be a difference of squares. It would be a squared minus 25y squared, right? Okay, so this problem's just a smidge fancier. Instead of a, we have 2x minus 3. But can you follow the same pattern? For the simpler case, I think we can. So instead of a squared, we're going to have 2x minus 3 squared minus 25y squared. Do you see that? That's my a. All right, now we're not done. Remember, we have to multiply out 2x minus 3 squared. So, oh yes, it's shortcut formula time. Square 2x. So it's going to become 4x squared. I'm going to put a minus sign down. And then remember, take the first term times the second term and then double it. So 2x times 3, that's 6x. Double it. 12x plus, square the last term, 9 minus 25y squared. And you know, we just got to leave it like that. There's no like terms to combine. Oh my goodness. Okay, lovely. Now, last example, let f of x equal x squared plus 7. Find and simplify f of a plus h minus f of a. All right, before we tackle this problem, I just want to get you guys comfortable with using function notation. So remember, they're telling us f of x for this problem equals x squared plus 7. If I asked you to find f of 1, what would you do? Yeah, you would replace x with 1 and then simplify, right? We don't need to simplify. What if I asked you to find f of 0? What would you do? Take 0 and plug it in for x? Good, yeah, you'd have 0 squared plus 7. What if I got real weird on you guys and I said, what's f of star? What would you do? Yeah, it's star squared plus 7, right? You just replace x with whatever you see in the parentheses. Okay, so what if I asked you for f of a? What would that be? A squared plus 7, yeah. And then lastly, f of a plus h. What would that be? Be careful. It would be a plus h squared plus 7, right? Good. So what the problem is asking us to do is to take f of a plus h, which I have right here, and subtract from it f of a. And I have f of a right here. See how I snuck that in on you guys? You didn't even realize it. Okay. Okay, so now let's just put it all together. So f of a plus h minus f of a is going to be f of a plus h, we have it down here, a plus h squared plus 7 minus f of a, that's right here, put parentheses, a squared plus 7. Good, and then now we just got to clean it up. So a plus h squared, oh, we're professional at that now. A squared plus 2ah plus h squared, keep that 7, and then distribute this negative. So we have minus a squared minus 7. Anything we can clean up? Clean up crew coming in. A squareds are gone, 7s are gone, and we are left with 2ah plus h squared. Actually, anything that didn't have an h should cancel out when you're evaluating f of a plus h minus f of a. Fun fact, you'll see why later when you get to calculus. So that concludes the lesson. Coming up next is common factors and factoring by grouping. And for all you calculus people out there, I am working on linear and differential equations. It's just going to take a wee bit longer, but thank you for all your support and patience. Be sure to like, subscribe, and share this with anyone else you think would find it helpful. Happy studying.